Hello everyone. Today we'll be solving AQA GCSE Chemistry June 2021 Foundation Paper. This is a part 3 video and today we're going to be solving from question number 8 to question number 10. This question is about carbon and its compounds. Fullerenes are molecules of carbon atoms. The first fullerene to be discovered was Buckminster fullerene, which is C60. What shape is Buckminster fullerene? Well, fullerene is in this case sphere. So we'll say spherical. Give one use of a fullerene. All right. So fullerene can be used for drug delivery in the body. Fullerene can be used as hydrogen storage. It can be used as antioxidants. It can be used for the reduction of bacterial growth. In some industrial processes, it can be used as a catalyst. Okay. Fullerene can be, cylindrical fullerenes can be used for strengthening materials. All right. Fullerenes can also be used as lubricants, dry lubricants. Propanone is a compound of carbon, hydrogen, and oxygen. Figure 13 shows the dot and cross diagram for a propanone molecule. Complete figure 14 to show a propanone molecule. Use a line to represent each single bonds. So basically, when we are drawing propanone molecule, there will be 3 carbons in a row. Each carbon will be connected with maximum number of hydrogen. Determine the molecular formula of propanone. So propanone contains 3 carbon. It contains a total of 7 hydrogens and 1 oxygen. Sorry, my bad. It contains a total of 6 hydrogens and 1 oxygen. Propanone is a liquid with a low boiling point. Why does propanone have a low boiling point? So boiling point is due to intermolecular forces. So if intermolecular forces are weak, it will have low boiling point. Figure 15 represents the structure of graphite. We can see the layer structure. It's a good electrical conductor. So explain why it's a good electrical conductor, and soft and slippery. The main reason why graphite is a good electrical conductor, it's because there are 3 covalent bonds. As you can see, there are 3 covalent bonds per molecule. So this leaves 1 delocalized electron, and the delocalized electrons are, it can move throughout the structure, which can carry electricity. So graphite can conduct electricity. And if you notice the layered structure, each layer, due to the delocalized electron in between the layers, allows the layers to slide past each other very easily. All right, which makes it soft and slippery. So I'll give you an example answer and try to include as many points as possible. This question is about atomic structure and the periodic table. Gallium is an element that has two isotopes. Give the meaning of the term isotopes. You should answer in terms of subatomic particles. So basically, isotopes are atoms of the same element with same number of proton but different number of neutrons. Table it shows the mass number and percentage abundances of isotopes of gallium. So we can see the mass number, we can see the percentage abundance. Calculate the relative atomic mass AR of gallium. To do this, we'll have to take the mass number multiplied with the percentage abundance and then take the second mass number and multiply with the second percentage abundance and then divide it by 100 because it's a percentage. So the answer comes 69.8 to one decimal place. Gallium is a group 3 of the modern periodic table. Give the number of electrons and neutrons in an atom of isotopes of 69, 31 gallium. So number of electrons will be 31. It is similar to that of the number of proton. And number of neutrons will be 69 minus 31. 31 is also the number of protons. So answer is 38. What is the most likely formula of gallium? Because gallium belongs to group 3, so gallium has 3 electrons in the outer shell. If it loses 3 electrons from the outer shell, then it's going to form Ga3+. Gallium was discovered 6 years after Mendeleev published his periodic table. Give 2 reasons why the discovery of gallium helped Mendeleev's periodic table to become accepted. Basically, Mendeleev proposed that there will be some elements in between, like he created the a periodic table with some gaps in between, and he proposed that there will be elements that will be invented in future which will fill up these particular gaps, and they will have these properties. All right, according to the group number, he predicted those properties, and then the invention of gallium fitted in a gap that the Mendeleev has left, and the gallium's properties were predicted correctly by Mendeleev. That's why it made Mendeleev's periodic table more acceptable. This question is about the extraction of metals. Element R is extracted from its oxide by the reduction with hydrogen. We can say hydrogen reacting with R oxide, and R is produced and water is produced along with it. The sum of the relative formula mass Mr of the reactant is 150. Calculate the relative atomic mass of R. So we have 3H2 plus RO3 equals to 150. Now 3 times 2 times each hydrogen is 1. We don't know R. We know that each oxygen is 16 times 3 equals to 150. This gives R is equals to 150 minus 16 times 3 minus 6. So the value is 96. Identify the element R. Use your answer to question 10.1. Alright, the periodic table. So if we look into periodic table, with the AR, relative atomic mass of 96, we will find it's molybdenum. So R is molybdenum. Carbon is used to extract tin from tin oxide. The equation of for the reaction is shown. Tin oxide reacting with carbon, tin and carbon dioxide is formed. Calculate the percentage atom economy for the extracting tin in this reaction. So atom economy always refers to the mass of useful product. Here the tin is our useful product, which has a mass of 119. And then divided by the total reactant. The total reactant is SnO2, which is 119 plus 16 times 2 for 2 oxygen and for 1 carbon 12. Then we're going to multiply all of this with 100 to give us percentage. So percentage atom economy is equals to 119 divided by 163 times 100. This gives us a percentage of 73. Tungsten, W, is a metal. Tungsten is extracted from tungsten oxide, WO3. All other solid products from the extraction method used to be separated from the tungsten. Must be separated from the tungsten. Table 9 shows information about 3 possible methods to extract tungsten from tungsten oxide. Reactant, carbon, relative cost very low. Product, tungsten solid, carbon dioxide gas, tungsten carbide. As you can see, these two might be difficult to remove unless or otherwise the tungsten carbide has a lower density. Hydrogen, relative cost is high, tungsten solid, and water vapor. As you can see, this is the best process because it only produces one solid, which is the pure tungsten metal. Iron plus tungsten oxide, the cost is relatively low. It produces tungsten solid and iron oxide solid. The problem is it is difficult to separate tungsten solid from iron oxide solid. Evaluate the 3 possible methods for extracting tungsten from tungsten oxide. So guys, one more time. With carbon and iron, we can see the cost is very low. However, the problem is they produce in method 1 and method 3, alright. In method 1, they produce tungsten carbide, which needs to be separated. In method 3, it produces iron oxide, which needs to be separated. However, in method 2, even though the cost is relatively high, it produces pure tungsten metal. So guys, the answer can be written as follows. So guys, this is the end of the question number 10, and that's all for today's video. All right guys, I will be uploading videos like this every day, and it would be really a big help if you could, like, subscribe to the channel, and regularly visit the channel to basically see your question papers being uploaded or not. You can inform me, you can message me, all right, you can write in comments so what question paper you actually need solved. All right, and best of luck for your exam. See you in the next video.